Hello, everybody. Welcome.
Hello.
Uh, I am Xavier Tissier, the Director of Operations at Vibrant Village Foundation. This is the first time we host a session like this, so the second week. And I hope we can organize more knowledge sharing sessions in the future if there is interest to support you beyond funding. Today, for a 1-hour session on regenerative agriculture. Then we will extend the session by up to 30 minutes to answer any questions that have not been addressed. If you can stay for the Q&A session, that's great. Otherwise, we'll record the session for future sharing. And I hope the connection will be stable. I see that it's a little bit unstable sometimes, but I hope you can hear me well and we can hear Roland. So today, I have already work on regenerative agriculture Africa, so I won't repeat it. But Roland can introduce himself quickly. And today we have about 34 participants from 8 different nonprofit organizations. A lot of people from Zimbabwe and also Malawi, Senegal, Uganda, and Kenya. So before we start, just to remind you about some of the tips I sent regarding Zoom. If you can mute your microphone when you don't speak, and if you want to speak, just unmute yourself. And happy to answer questions as they come. So don't hesitate to interrupt him during the presentation, or you can post your questions on the chat. So he will answer a few questions during the presentation, and then all the unanswered questions will be discussed at the end of the hour. So now we'll turn to Roland. Roland, up to you, and I will be the silent facilitator in the background.
Okay, well, first of all, I guess for most of you, I should say good evening. Here it's morning, but yeah, I think it's evening there in most places. My name is Roland Bunch. I've worked in agricultural development since 1967. I'm telling my age now. But in 1983, we began working seriously with what we call green manure cover crops. These are plants that fertilize the soil and do a whole lot of other things for people. We began working with them because we realized that synthetic fertilizer or chemical fertilizer was going to be way too expensive in the future. The price of energy around the world was going up and was going to continue going up. And in fact, it's at least tripled since those days. And as a result, chemical fertilizer has also at least doubled, if not tripled in price, which means that for most smallholder African farmers, it's completely, not only is it very expensive for them, it's anti-economic. They can't make money growing maize or sorghum or millet or cassava and using chemical fertilizer, because the fertilizer costs more than the increase in the value of the increase in yields they get. So we'll start here with a PowerPoint presentation. The first picture is the title of the talk, which is the use of green manure cover crops to fertilize the soil and end droughts. And you can see a farmer here. Actually, he's from Honduras. But first of all, you can see the really good-looking maize behind him. It didn't used to be that way. He's showing us in his hands that in his left hand, the one ear that he used to get from each plant, now he gets 2 ears the size of the 2 in his right hand. That almost tripling of yields means that he no longer has to go work on a sugar plantation. He can stay at home, and furthermore, probably the most important thing for me the thing I really am happy about in this photo is that his son is still in the village, just like in Africa, in Honduras, and many Central American countries. The young people have all gone to the cities because they don't see any future in the farms. And the way things are going right now, they're absolutely correct. There isn't any future. But especially with the increasing droughts that we have in all over, Western Africa, Southern Africa, and East Africa. But this young fellow, like many people we've worked with, both in Central America and now more recently in Africa, is he knows that his family's farm is going to be producing very well for at least another 30, 40 years. So he's staying out in the village and helping his father, and eventually he will have a good farm that produces well. Next. Okay, what's causing these droughts? I mean, people realize all over drought-prone Africa, pretty much all of Western, Eastern, and Southern Africa, that the droughts are getting more frequent and worse. And at a rate that within 10 or 15 years, there may not be any life to be had out in the villages. The land is getting very bad. A lot of it's become wasteland that doesn't produce anything. And, the situation is getting worse really quite fast. Okay, what are the causes? Climate change is a cause to some extent, but most people think that's more important than it really is. What climate change is doing is not reducing the total rainfall very much. In fact, hardly at all. What it is doing is making the rains more unpredictable. You never know when the rainy season is going to start. Whereas 30 or 40 years ago, people planted by the calendar. Nobody plants by the calendar anymore. They don't plant on, say, the 25th of November or something like that. They have to wait until the rains come, and they never know when they're going to come. And the other thing that climate change has done is to concentrate most of the rain in fewer and fewer on fewer and fewer days, and then leave sometimes a week or 2 weeks between periods of rainfall right in the middle of the rainy season. So that affects yields. But by far the most important reason that we're having droughts is that people about 20 or 30 years ago had to stop doing forest fallowing. They couldn't let the forest grow, what some people call slash and burn agriculture. They can't do that anymore because they don't have enough land. Population pressure on the land's increased. People are down to 1.5, an average across Africa of about 1.5 hectares per family. And as a result, they can't have forest growing on 3/4 of their land all the time because there would not be enough land left to feed them. So what's happened is that the organic matter content of the soil has gone down from about 4%, which it still was in the 1980s. And we should realize that for 2,000 to 3,000 years, forest fallowing kept Africa's soils fertile. It was a very good system, as long as people had enough land. Now that people don't have enough land, what we really have to do is, and this is what we're doing with green manure cover crops, is to really bring the forest into our fields again. Now, we can't do it the same way they used to be because then you couldn't grow any of your crops. But we can now, we know ways, and this is what we'll be talking about, we know ways of growing plants, trees and bushes and crawling plants and climbing plants. We can grow them right in our maize fields in such a way that we can produce 2 or 3 times the maize we now produce. And at the same time, the soil is getting better and the soil is becoming more drought resistant, so that our crops can enjoy the quality of soil and the moisture that exists in forest soils. I mean, I think probably most of you have been out in the fields enough. You've seen that in the forest, even during the droughts, the soil stays fairly moist. We can do that with our fields too. We just have to use the right plants in the right ways. And that's what we're talking about. Now, the decrease in organic matter in the soils that's occurred over the last 30 years has reduced the rainwater infiltration. In other words, the rainwater that falls doesn't soak into the soil, it runs off. It's reduced the infiltration from 60% down to less than 20%. So that means that farmers effectively are getting about a third of the rain they used to get just 30 years ago or 40 years ago. Next. Okay, by the way, if anybody has a question as we're going, it's often better to ask the question in the moment because we're looking at photos that can help answer the question. So if you have a question, go ahead and ask it. Please don't feel bad about interrupting and asking your questions. Okay, so what can we do about this problem of the increased droughts? Can you hear me now? Okay. The only feasible solution for increasing organic matter in our fields of basic grains is to use green manure cover crops. Why? Somebody needs to mute their. Okay. Why? Smallholder farmers do not have enough animal manure to do this. I mean, it's to really increase the fertility on a hectare and a half. Can somebody mute their computer? To use animal manure to increase the soil on a hectare and a half, you would have to have something like 12 to 15 cattle. By the time somebody has 12 to 15 cattle, they're not really very poor anymore. Very few farmers have that quantity of organic matter, of animal manure. Composting is even less practical. Green manure cover crops can produce 30 tons or more per hectare per year. That's wet weight or green weight of organic matter. Have you ever seen a farmer produce even 10 tons of compost in 1 year? That's virtually impossible. I've only seen it maybe 2 or 3 times. Okay, so neither compost nor animal manure in neither case are you gonna have enough to improve your soil. With green manure cover crops, you can produce anywhere from 30 to 60 tons per hectare per year, and that is enough so that your production will increase rather significantly. Next. Okay, here's a photo from an experiment that a smallholder farmer did, once again in Central America. But you can see there's, on the left-hand side of the photo, there's maize that's about 2 meters tall. Then there's one row that's a little bit yellower, that's about maybe 1 meter tall. And then you have, where the arrows are, you have a whole row of maize that's barely as high as your ankle. The interesting thing about this is that the farmer tried out this experiment because he had real doubts about what organic matter could really do. So he made about 15 or 16 compost heaps and turned it into the soil on the left-hand side of the photo and didn't put any on the right-hand side. All that maize, both on the left and the right, was planted the same day, and it was the same seed. The only difference is that he turned over the soil and put a tremendous amount of compost in it, okay? So there you can see what organic matter can do. And in 95% of the soils around the world, you can get this kind of results if you have enough organic matter. The important thing is that you have enough organic matter and that have enough nitrogen in it, okay? But this sort of increase in yields is possible in the vast majority of African soils. I've seen it happen in at least 12 different countries in Africa. Okay, next. Okay, what are these green manure cover crops I'm talking about? Here's the definition. A green manure cover crop is any plant, whether it's a tree, a bush, a climber, a crawler, and even in some parts of Asia, waterborne organisms that farmers use, among other reasons, to fertilize the soil, control weeds, and overcome droughts. Okay, next. Here's a list of the advantages, and there's more than just, we'll see some more in the next photo. First of all, they can triple present yields of basic grains, okay? The average farmer using traditional methods in Africa right now is producing somewhere usually just under 1 ton per hectare of maize, okay? Sometimes if things are really bad, they'll be producing half of that. In a period, now it does take some time, but in a period of 3 to 4 years, they can usually double that. They can usually be producing 1.5 to 2 tons. In 5 or 6 years, if they're doing things well and they're using a relatively decent system, they should be producing 3 tons, 2.5 to 3 tons of maize per hectare. It does take time. People have to have a little patience, but we have found that farmers have a tremendous amount of patience when they realize what's possible and how much change they're gonna achieve after a few years. These same plants can often produce a large quantity of additional food rich in proteins. Now, at the beginning, oftentimes we have to use green manures, cover crops that are very resistant to drought, very resistant to poor soils, and therefore they don't produce food usually. But after the second or third year, we can usually switch to something like, for instance, in many of the areas where you live, we can use lab beans or pigeon peas, and we can produce a lot of very high protein food, in addition to increasing the maize, sorghum, millet, or cassava that farmers are growing. So basically, in a period of 5 to 6 years, virtually every farmer in sub-Saharan Africa should be able to produce all the food they need on even just 1 hectare. Okay. Okay. In other words, and furthermore, they're getting proteins as well as vitamins and minerals, because most of the plants we use are legumes, and of course, as you know, legumes are high in proteins. 3, combined, these 2 factors can end hunger among the vast majority of farm families in the developing world. And this is as true of Africa as anywhere else. Number 4, they can also reduce the labor needed to control weeds. This, of course, in much of Africa for women is a tremendous decrease in heavy labor, which they often have to do right in the middle of the hunger season. And so that can be tremendously important. Anytime I talk with a group of people in a village, I tell them that I want to have women in the group as well as men, because the women will usually favor green manures even more than the men will. And another job that women have that is decreased is if you have among your green manures certain trees, those trees will also provide firewood, so the women don't have to go all the way to the forest and climb trees to cut the firewood out of them. They can just go to the field and usually just pick the branches off the ground. So that also reduces their labor considerably. Next. Okay, now this is one that's hard to believe, but I'll show you a couple of pictures in just a minute. These green manure cover crops can reduce the impact of droughts by up to 80%. In other words, now after 4 or 5 years, and this does take 4 or 5 years, or even 6 years, but people will start to see the impact on droughts usually by the 3rd year. And by the 6th year, like I say, they'll be producing 3 tons per hectare in a good year. And in bad years, when people who aren't using green manure cover crops completely lose their harvests, lose their crops, the fields where they've been producing green manures, using green manures for 5 or 6 years, will produce 2.5 tons. In other words, 80%, approximately 80% of what they get in good years, which is 3 tons. So they can be producing still 2.5 tons in a year of drought when everybody else is losing their crops, and they would have lost their crops if they hadn't adopted green manure cover crops. This is probably the thing that most motivates farmers, even more than the soil fertility, is not having to go through drought years and basically experience hunger. In fact, I often hear agronomists in Africa, or African agronomists, saying that African farmers, smallholder farmers, are unwilling to change or unwilling to adopt new technologies. In fact, we're finding now that with the droughts as serious as they are, once they realize that these plants can overcome the droughts, I can talk with a group of farmers in almost any village in Malawi or Tanzania or Zimbabwe or Kenya, Uganda, Mali, Malawi, Ghana. I've worked in all these countries, and within 5 minutes, people are asking me for seed of the green manure cover crops. You know, this is something they really want to try out. And like I say, the most convincing thing is that even though they're going to have to wait 5 or 6 years, controlling the droughts is something they dearly wish to do, because they realize that their whole way of life is going down the drain. Their whole way of life is being destroyed by droughts. And a lot of people now in Africa, it's taken a long time, but I think a lot of people, a lot of farmers in Africa realize that these droughts are just going to go on and get worse and worse and worse until they do something about it. And the best way, by the way, to convince people of this is to talk about the soils and what happens in a forest. Most of them have fairly dense forests somewhere in the area where they collect firewood and so forth. And they know that in the forest, the soil stays quite moist during the entire rainy season. And you know, very few plants in a forest ever die because of the droughts. And furthermore, the soil is fertile in the forest. And so if you say basically what we're doing is taking plants out of the forest and putting them in our fields, the ones that most fertilize the soil and the ones that most keep our soil moist, they can understand that very quickly and become quite convinced that it could happen in their fields too. Okay, number 6, what's the other advantage? They can sequester carbon in the soil. Now, this is not that important for local farmers, but it's important in terms of the whole world and getting rid of climate change. I won't go into the statistics here, but if all of African farmers, smallholder farmers, were to use green manure cover crops, and we're hoping we can get to a position like that in about 25 years, climate change, we would have done a great deal of work to reduce climate change. Number 7, green manure cover crops can produce a good deal of other products such as firewood, medicines, year-round fodder, year-round high-protein foods, rodenticides, et cetera, et cetera, et cetera. Next. By providing a moderate shade for crops and increasing soil moisture, farmers can go a long way toward very cheaply protecting their crops from the impact of global warming. In other words, green manure cover crops are a very efficient form of climate smart agriculture. 9, they can also reduce overall costs by eliminating or reducing weeding labor, eliminating or reducing tillage. I mean, basically, most farmers after 3 or 4 years of green manures no longer bother to plow their soil because it's so soft because of all the green manure, organic matter. It's so soft that they don't need to. Some of you may remember that your fathers or grandfathers, when they were still using forest fallows, they didn't plow their soil the first year after they cut down the forest because the soil was so soft it wasn't necessary. And that's true if you're using green manures each year. They also produce firewood right in farmers' fields. Next. Okay, in the background there, the fields that the farmers there are pointing to, the upper half of that field has had green manure cover crops for 2 years. The lower half has not. Next. Here are the same 2 fields. And you can see behind the woman there, the woman farmer, you can see that she's producing at least 4 or 5 times more maize than the maize in the foreground here will produce. That's because of 2 years of green manure cover crops. Now, in this case, things worked out very, very well. Usually it takes longer than that. Usually to get a increase of 4 or 5 times like this, it takes 5 or 6 years. And a lot of times people never do quite produce that much of a change. She's starting out with a particularly low yield. Nevertheless, this sort of increase over 5 or 6 years is possible virtually everywhere, in Africa, outside of, in the Sahara Desert. Next. Okay, now this and the following photo, which we'll look at for a little minute here. This photo and the following photo show you what can be done in terms of drought resistance. This is a traditional system that was discovered by farmers, a traditional green manure cover crop system discovered by farmers in Madagascar. And this particular farmer, we're looking at a field during a drought year. You can see the leaves are all curled up. It's been a bad drought. The green manure cover crop on the ground is not doing well at all. This is the first year. In other words, the year before this farmer probably didn't get hardly any harvest at all because of a drought. In this case, you can see the production is going to be very low. The leaves are all curled up. The ears of corn, where they do exist, are very small. And, they're going to have a bad year. Now, next. Next. Javier? Yeah, okay. No, that was too much. Backward. Okay. This field is on the same farmer's land, the same day. So it had been through the same drought, and yet look at the productivity. The only difference between this field and the other field is that here she has planted this same green manure cover crop for 6 years. In other words, this is the 6th year. Okay, that's the only difference. And in fact, if you have I'm sure you have a hard time believing that. I did too. But if you look at the cloud, let's go back one more photo, Xavier. Backwards. Xavier. Okay. If you look at the two clouds on the right-hand side of this photo, there's a sort of a roundish cloud, and then there's a cloud that has a very thin, on the left-hand side, it has a point, okay, a very thin point. Those two clouds, if we look at the next picture, next, Javier, next. Next. Okay, we'll see those same two clouds in the right half of this picture, the round one, and then right in the center of the photo, the cloud that has a point on the left-hand side. Those are the same clouds. So these pictures were taken in the same field, the same day. And the only difference, like I say, there's no chemical fertilizer or anything. The only difference is that in the first, I take that back. She did apply a very small amount of chemical fertilizer on both of these fields, the same amount on each field, and a very small amount. In the first field, she'll harvest, if she's lucky, 1/2 ton of maize, maybe a little more. In this field, she'll easily harvest 2.5 tons. Okay. You can see that this has gone through the drought, because where the vetiver grass is there, you see a few leaves that are slightly curled. But if you look over on the left-hand side of the photo, the leaves are very nice and green because of all the nitrogen that's been provided by this green manure. And you can see some very, very nice large ears of corn, ears of maize. That's the difference that green manure cover crops can make in the drought resistance of fields. And like I say, it'll take 5 or 6 years, but the difference is tremendous, and farmers will be extremely pleased. Are there any questions? Okay, this is the part of the whole thing that's most difficult for people to believe, is the idea that you can have this kind of an increase in yields just because of plants that you grow in your field. In this case, it's a 9-month cowpea. I understand that in eastern Zimbabwe, that it's a very rare plant, this 9-month cowpea. But I understand that in certain parts of eastern Zimbabwe, people do have 6 to 9-month cowpeas. If that's the case, these can be wonderful, wonderful green manures. And I'll tell you why in a minute. But if you know of cowpeas that are 6 to 9 months old, and like I say, those are very rare in Africa and Latin America and in Asia, that you have a gold mine in your lab. Next.
Roland, Elliot from Zimbabwe has a question.
Oh, okay. Yes.
Thank you very much, Roland. I'd actually written the question, but let me just ask. I wanted to find out what are the major obstacles to the green manure cover crop technology,
right?
When we have such success stories, you know, as you noted, actually.
Yeah, I'll go through those in a minute. So I'll hold that question until I think I have a list of problems that we can confront in just a minute. Okay. Thank you for the question.
Okay.
Okay. Now, this is another thing that we often misunderstand, especially those of you who have studied agronomy in grade school or in high school, secondary school. Tropical green manure cover crops are also able to fix a lot more nitrogen than our textbooks admit. The reason for this is that virtually every textbook you've ever seen on tropical soils was written by either one or several authors, and at least one of those authors is an active employee of a fertilizer company. Fertilizer companies don't want you to know about this because by using green manure cover crops, you don't need to use anywhere near as much fertilizer and probably none at all. So you know, the textbooks will show you roots that have maybe one little ball one little ball, white ball, about every 2 or 3 inches along a root. These are the nodules that they talk about in the textbooks. Well, they don't have any idea. Either they don't have any idea or they don't want you to know that in fact these plants are capable of fixing a whole lot more nitrogen than one little ball every couple of inches along a root is going to produce. These here in the picture are the nodules from one mucuna plant. Mucuna is one type of green manure cover crop. That's from one plant. Now this plant was grown specially. The farmers in these cases were just trying things out, so they kept the area around this one plant weeded, so it had no competition at all from anything. But this is what one mucuna plant in 6 or 8 months can produce. These are all nodules that have nitrogen in them, just like urea, the fertilizer you pay so much money to buy, and they will have the same impact on your crops. By and large, African farmers don't need to use any chemical fertilizer once they have green manures that are working well. The green manures will produce, the mucuna, for instance, this particular one will produce up to 150, and this is according to United States textbooks, will fix up to 140 kilos of nitrogen per hectare. That's 3 times what you'd ever need in an African field, okay? The one we often use in the beginning to get the soil really improved quickly when we're working in an area, it doesn't produce any food, but it does produce 240 kilos of nitrogen per hectare, which, like I say, is probably 6 times what any African farmer would ever need to have a really, really nice maize crop. So we're talking about levels of nitrogen fixation and levels of improvement in yields that most people have no idea are possible. Next. Next. Okay. The most important rules, now we don't have time to go through all the different rules for managing green manure cover crops because that takes a while. And VVF hopefully is going to be able to get you a book that I've written on this subject. Well, you can't see it, but anyway, that it's 200 pages and it tells you virtually everything you need to know about green manure cover crops, but it is 200 pages. We can't get through that in 1 hour. But here are the rules. Okay, and each of these rules is to overcome a problem. The first problem here is that when you have approximately 6 months of rainy season and 6 months dry season, then you have if the green manure cover crop if it dies at the end of the wet season, then there's not gonna be hardly any nitrogen and very little green biomass or plants leaves, green leaves that are still fertilizing your soil when you plant the next year. With 6 months of heat in the lowland tropics, you've lost almost all your fertilizer. So the golden rule of green manure cover crops is that their green leaves must be on the ground at the time, and they must be green or close to green on the ground at the time that farmers plant their next crop. So something that won't grow through the dry season, for instance, a 4-month cowpea, which is the normal, 3 to 4 month cowpea, all the material lies on the ground for 6 months of dry season. By the time you plant your maize or sorghum or millet again, there's no fertilizer left. Okay, this is the biggest problem probably that we have. We have to find some way to get these plants to go through the dry season. So we either plant something like lab, which will grow through the dry season just because it's extremely drought resistant, or we produce pigeon peas, which will also grow through the dry season, but which we can just cut down when we're ready to plant our maize again, and all those green leaves will fall on the soil and be wonderful fertilizer. That's the biggest problem with green manure cover crops. They have to continue to be green, like the 9-month cowpea I just mentioned a while ago, the one in Madagascar. They have to stay green until the next rainy season comes. In parts of Kenya and Tanzania, Uganda, where you have 2 rainy seasons, this is not as big a problem. But it still is best if you have something that grows for 6 months, and in that case, and can fertilize your crops for the next rainy season. 2, farmers are presently using more than 100 species. Therefore, we must find out which species will work best in each particular area. This is the biggest problem with green manure cover crops, finding out which ones are the best for each area. And that's where I can probably help each and every one of you, because I've worked in all the countries you live in. So, and we already have very successful green manure cover crops that are growing in Zimbabwe, Zambia, Malawi, Tanzania, Kenya, Uganda, Mali, northern Ghana, etc. Okay, next. Next. Okay. Unless they also produce food, we cannot grow green manure cover crops in the place of farmers' food crops. In other words, the idea of rotating maize one year and a green manure cover crop the next year on the same land is just not going to be acceptable. Farmers want to be able to grow food on every bit of their land every year, unless they have 2 or 3 hectares or more. But the vast majority of smallholder farmers these days are going to want to be able to plant food on all their land. So we must grow the green manures either below, above, or intercropped with the crops already growing in farmers' fields, or during the dry season, or using some combination of these. In other words, oftentimes, for instance, in southern Malawi, right now, there are about 1,000 farmers. Because of our work, there are about 1,000 farmers now who are growing Gliricidia trees above their crops, which they prune each year, so the shade is little enough so it in fact helps their crops rather than hurting them. And then they also grow in among their crops, they grow pigeon peas, which many of them already know how to eat. They grow pigeon peas, which also provide a tremendous amount of organic matter that's high in nitrogen and so forth to fertilize the soil. And under that, they can also grow, although this they aren't doing quite yet, but some of them are just starting. They can grow something like cowpeas or well, any one of a number of other soybeans, et cetera, under pigeon peas, because the pigeon peas also let a lot of light through. So in other words, and these people are getting, they're already getting double the yields they used to get and seeing quite a bit of resistance to drought. So, you know, these things are already happening in with different systems in virtually all the countries you people live in. 4, imitate the forest. This is a really important rule. Over time, now we're not going to do this the first 2 or 3 years or even the first 5 years, but over time, the fields should come as close to imitating the forest as they can while still leaving the spaces necessary to grow maize or millet. Well, in most of Africa, our experience is that when people have improved their soils, they stop growing millet and they start growing maize because they really prefer maize over millet. The farmers in some of the farmers in southern Malawi were growing millet when we started working there a few years ago. And as far as I know, none of them are growing millet anymore because the soil is good enough to produce maize, and they really prefer the maize. So what we're really trying to do over the long run is sort of imitate the forest, get 4 or 5 different plants in there that are growing along with our crops, helping our crops grow better, and providing an environment in which basically droughts don't exist, and in which we can grow quite a number of different food crops, even vegetables in some situations. 5. Next. Okay. The other problems, the problems then, to answer the question that was already asked, are getting the plants to grow through the dry season, finding ways of places and ways of growing green manures that don't reduce the space necessary for people to grow their food. And in this case, and also another problem that can sometimes occurs is that we have pests, like for instance in southern Malawi, termites started affecting the experiments where people were growing pigeon peas. The interesting thing that we found out was, though, that if we grow pigeon peas together with maize and together with Gliricidia trees and together with 1 or 2 other plants, then the termites don't affect there's enough organic matter there that's dying that the termites can eat, so they don't affect the live plants. So that basically has solved the problem. We thought for a while we weren't going to be able to grow pigeon peas. Now we found that if we're growing the pigeon peas in maize fields with Gliricidia, with maybe 1 other green manure cover crop, then the termites don't bother the live plants. So those are the basic problems that we have with green manure cover crops. And then of course the other one is choosing the right one. There will be some green manure cover crops that are much better in any given situation than others, and we have to find which ones the farmers like best. So those are the problems. Yeah. Did somebody else want to ask a question? Okay, next. Next. Okay. Here's the case. This is the plant we often start out with when soils are really bad and drought is very serious. This is a bushy style jack bean. Carnavalia ensiformis is the scientific name. It's very resistant to poor soils. It's very resistant to drought. And you can see in this photo that probably 90% of all the maize plants died because of a drought. But the jack bean, which is all the green that's under the maize, the few maize plants that are there, all of the jack bean has grown very well. Looks like it was irrigated yesterday. Okay, it can fix 240 kilos per hectare, which I already mentioned. And it's therefore ideal for initiating the process of soil recuperation if the situation is already pretty bad. Okay, next. Here's another way of growing jack bean. Here it's intercropped with cassava. This means that the cassava is now producing 3 or 4 times what it used to produce, but also very important is that there's no weeds in that field outside of right near the camera here because I was on the side of a road. But in the field, there's virtually no weeds, and that's because the jack bean has controlled the weeds. Usually, in maize or cassava fields, you'll have to do a first weeding, but by that time the green manure like jack bean has gotten big enough so that it'll completely shade out any other weeds. And so you completely eliminate the second or third weeding. Next. Okay, here's another very popular plant that we use in many areas. This is very, very popular in Kenya because the Kikuyu people consume tremendous quantities of lab bean. This is the lab bean. It's growing. This is 2 or 3 months after the maize has been harvested. We're well into the dry season, about 2 months into the dry season. And you can see it's still not only growing, but producing seeds. So this will produce high protein bean for 5 months, right into the growing, right through the growing season, the hunger season. And, you know, and then it's a wonderful fertilizer for the plants. It's a wonderful fodder for animals, and it's a wonderful food. The leaves also can be, we learned from farmers in Zambia that they can dry them. You can dry the leaves very easily, store them for 12 months, which means you have a very good source of protein, vitamins, and minerals that's available all year long. We're talking about eliminating hunger, and we're serious about that. With the lab beans, you know, we'll produce a tremendous amount of beans for 6 months, and then you can eat the leaves, you know, for the next 6 months, or eat them at the same time, whatever you want to do. Now, the one thing with lab beans is that if you just cook them like any other bean, they aren't very good tasting. But we have recipes, very simple recipes that, for instance, the Kikuyu people use in Kenya, and many people use in northern Tanzania, that make them very, very tasty. Next. These are Gliricidia trees, and they're in central Mali, which has, you know, it's a very droughty area, and yet we got 95% survival rate after the first year, and about 90% by the 5th year. So they've done very, very well. They can be pruned very easily. You prune them standing on the ground, and you prune them each year before you plant your crops. You can see, if you look on the ground, you can see that there are ridges, and the ridges go right up to the base of the plants. So in other words, farmers are planting just as much maize as they ever did in this field. They don't have to leave a row for the trees. And the trees will provide not only firewood for the kitchen and a tremendous amount of biomass to fertilize your fields. They will fertilize the fields extremely well. They also, but they also provide a light shade for your crops, which means they grow even better and they survive the droughts even better. And at the same time, these leaves, and this is frankly the most popular thing about the trees, not so much that they increase the soil fertility, but what these farmers in central Mali really like is that all those leaves that are coming out 2 months before the wet season comes, this is toward the end of the dry season, they have enough leaves to keep their animals. If there's been a drought the year before, they have enough leaves to keep their animals from dying the 2 months before the dry season. In other words, in April and May in Mali, which is the end of the dry season, they have plenty of fodder for their cattle, so their cattle no longer die when all the rest of the food is gone. You can see on the ground there's nothing left for animals to eat, but the leaves in those trees are a very, very high protein fodder that does a very good job of keeping the animals alive until the rains come and there's grass all over the place. So these trees have about 4 different functions. And they have some others I won't bother to mention, but you know, these can be very, very valuable for your crops. Next. How are we doing time-wise, Xavier?
I have 6 minutes left.
Oh, okay. Well, we have
so I
plenty
think
of time.
you're good. And you have a question from Tafatswa from Zimbabwe.
Okay, great.
Tafatswa, if you want to unmute yourself, or I can read the question.
Well, if he's there, I'd like to hear it from him.
Hello.
Hello?
Yes. I was worried on the issue of green manuring in cover crops. That is on the golden rule, which stated that green manuring in cover crops leaves should be on the ground during
Yeah,
the
the
time
leaves,
of planting.
the leaves should be at least fairly green. We need to cut them off the tree, right, or the plant, cut down the plant or prune it or whatever, right before we plant our next crop. Which country are you from?
Zimbabwe.
Zimbabwe.
Should they be
Okay.
on the ground? Yes.
Okay. In Zimbabwe, you have two rainy seasons.
Yeah.
Yeah. So the rains come in approximately in November, right?
Yes.
So what you want to do is have something that you plant with your maize in November to December or January, and then it grows all the way until the following November. And that's not that, you know, that will that there are only a certain number of plants, maybe 6 or 8 of the plants we use that can do that under difficult conditions. So that's what you need to
Okay.
do. Was there more to your
The
question?
issue is, hello. The issue
Yeah.
is during the time of planting, for the green manure crop to save its purpose, it should be plowed under and it shouldn't be on top.
Yes, virtually all the green manure cover crops that we use will be planted in southern Africa. In Zimbabwe, will be planted in November when the rains come. November, December, January, whenever the rains come. Now, once in a while, in an area, usually this would be more appropriate in Uganda or Kenya or maybe even southern Ghana, where they have 2 rainy seasons. Then you can plant, for instance, you can plant jack bean during the dry season, and it'll grow right up until your next crop. You know, so you don't even have to intercrop it with your other crops. So that is a possibility. But in Zimbabwe, where you have one rainy season and one dry season, it's best to plant something like all the crops I've shown you as specific green manures right now, the jack bean, the lab bean, and the Gliricidia will grow right through the dry season. Now, there is another problem in that case, and that is what do you do if there's a lot of cattle roaming, which is usually the case. You know, if you have free roaming cattle, they'll come and eat everything. Well, they won't eat the jack bean. So if you have that and you have no way of making fences, then jack bean is a very good crop to grow right through the dry season. The cattle won't touch it. It's not good for them, and they know it. So you can do that. But that has the disadvantage that you're not producing any high protein food on your jack bean. The only thing it does is grow really well and fertilize your soil. And well, it does several other things. But now, if you want to use lab bean and the soil is good enough so lab bean will grow, then what you're going to have to do is use a fence. And in some areas, I think, of eastern Zimbabwe, certainly in Mozambique and South Africa and southern Malawi, we have a plant that's called the monkey thorn tree. It's an Acacia galpini. The monkey thorn tree makes a wonderful fence, a live fence. You can plant it. Within 1 year, it will keep cattle and goats out, and it will continue to grow for 80 to 100 years. You don't have to replant it. All you have to do each year is prune it, and during the dry season, keep the fires away from it. And it's very, very popular right now in Malawi. Farmers are planting thousands of kilometers of this monkey thorn fence so that they can grow their green manures inside of it. Okay. Okay, other questions? Xavier, maybe you have some questions. Why don't we go ahead and go to the questions?
So we have one question from Benson. And I think now we are moving to the Q&A session. The presentation is at the end now, so
well, there's a couple of more
have...
slides, but they're specific about Gliricidia, so we don't have to look at those right now. Yeah, go ahead.
Benson, if you want to go ahead, and anybody else, if you have questions. So I can read Benson.
Yeah, go ahead and read the question.
Yeah. Okay. So the question from Benson from Kenya is, they have tried out LabLab and Glyceridia, but one of the challenge they experience is measuring biomass.
Measuring biomass.
And
wow.
Yeah, and the question might not be finished. I don't know, Benson, if that was the end of the question. But
yeah, basically you can use any kind of a scale you use to weigh maize or anything like that. You can weigh the biomass, although it's going to be a job because there's a tremendous amount of biomass. Now, another thing I should mention, both with LabLab and Gliricidia, well, actually any of these are all for lowland areas. There's certain parts of Zimbabwe that are going to be too high for these species, and you'll have to use different species in that case. There's also areas in Kenya that are too high. If you're over about 1,500 meters in elevation, the LabLab isn't going to grow very well. If you're over about 1,000 meters in elevation, the Gliricidia is not going to grow very well. The jack bean will also grow up to about 1,500 meters. So, if you're above those levels, then you're going to have to use something else like runner beans and alder trees and things like that we can get into. But I think most of you, probably outside of Zimbabwe and maybe Kenya, are working at lower elevations.
Elliot,
so in terms of weighing the biomass, if you want to, what I would do is pick a 10 by 10 meter plot, weigh the biomass, weigh the leaves and everything in that area, and then to find out how much is going to be in a hectare, you'd multiply that by 100, because there's going to be 100 plots of 10 by 10 meters in each hectare. So that would probably be the best way to weigh it, and you'd need some sort of a scale, market scale or something like that.
Elliot, do you want to go next with your question? And then there is a question from Twissy also after.
Okay.
Thanks, Xavier. I wanted to find out from Roland in terms of country-specific species and their availability. How accessible are these varieties, so that we can really start rolling out this very interesting technology.
Okay. Yeah, the seeds, in some countries, certain seeds are difficult to get, in other countries, not so much. Which country are you from?
From Zimbabwe.
Okay. Write me an email. I have a friend who lives, he's a Zimbabwean farmer who lives in northern Zimbabwe, and he has almost all these seeds, and he can sell them to you. Okay. So
Okay.
that would probably be the best way. That would probably be the best way to handle it. Now, some seeds, are already quite widely available in Zimbabwe. I know Mukuna's widely available in parts of southern Zimbabwe because it's used as an animal feed. But I don't recommend Mukuna very often. Usually we have green manures that are much better than that. So, but write me, let me know which seeds you want, and I will send you the email address of this fellow in northern Zimbabwe.
Okay.
Or for instance, There are some places that I know of in Zimbabwe where people are already using quite a bit of lab. So, you know, if I know where you live and which seeds you want, I may be able to find even a source that's closer to home.
Southern part of Zimbabwe, you talk of Masvingo.
Okay. I don't know specifically there, but I do. Yeah, I really don't know that area very well, so I can't tell you where the seeds are available.
That's fine. My hope is that probably seeds is the only one with the seeds. He may not be charging premium prices.
Oh, no. This fellow that has this fellow in northern Zimbabwe, he doesn't charge very much for the seeds. Furthermore, a farmer, we don't use a plant as a green manure cover crop if farmers can't produce their own seeds. So all really a farmer should get the first year is a handful of seed, because he or she should only buy enough seed to establish a good experiment, because farmers should always experiment with these things before they do it on a large scale. So have each farmer get a handful of seed. It shouldn't cost more than you know, maybe a handful of seed would cost 20 cents of a US dollar, and then have them experiment with that, and then they harvest their own seed, and they'll have enough for maybe half a hectare or a whole hectare, depending on what species it is. So, you know, they never have to spend much money on seed, and they never have to buy seed every year. That we aren't willing to make farmers dependent on outside sources. We want farmers to be able to grow their green manures without buying any seed after the first year. So, you know, even if he were selling it expensive, the most you'd have to pay is maybe $50 to get a handful of seed. But he won't do that. Okay?
Yeah, brilliant.
But don't have anybody ever plant these things on a large scale, because, for instance, if they plant the wrong kind of jack bean, it'll grow up their maize and cover it and kill it. You know, and they may not realize they need to prune it. So you know, they should always experiment on a small scale. If they like the results, then they can go large. Another thing that you can do that's really important oftentimes is take some of the plants off, some of the leaves off these plants the first year, and use them to fertilize vegetables, because vegetables will, you know, if you take the leaves off of for instance, a lab plant or a Gliricidia plant and put them on tomatoes, put 2 or 3 handfuls on each plant of tomatoes in a very small experiment, you'll see those tomatoes will grow like nothing they've ever seen before. And so then they realize, oh, wow, these things really are good fertilizer, you know, and that will motivate farmers to, because since the green manures take 2 or 3 years to really show dramatic results, that will convince them that it's worthwhile waiting and worthwhile continuing to work with them. Okay?
Thanks.
But farmers should, anything I tell you, farmers should try it on a small scale first in order to see whether they like it, in order to see whether they've learned how to do it right, in order to see whether what the results are before they start doing it on a large scale. Okay, next.
So we have a question from Twisi from Malawi. Twisi, if you want to ask your question, and then from Pascal from Zimbabwe.
Okay.
Oh, thanks, Xavier, for introducing me to Roland. And thanks, Roland, for the elaborate presentation on green manure and cover crops. I see that this is a very interesting innovation in terms of improving productivity at a less cost against the chemical fertilizer farming business, which is killing smallholder farmers, especially here in Southern Africa. But I want to understand in terms of the timing for planting the green manure or cover crop. In terms of, should we do it like in the way the traditional rotation system of intercropping or relay farming? Basically, for the purpose of how do we get the most benefit?
Okay, we get the most benefit in the case of the 3 species I've talked about. Well, 4 species I've talked about most. the lab, the Gliricidia, the jack bean, and the pigeon pea. Every one of those should be planted intercropped with the maize or sorghum or millet or whatever they're growing now, so that you still are growing just as much food as you ever did. You know, we don't want to take land out of maize production, for instance, and put it into green manure cover crop production. People won't accept that. They won't reduce the amount of land they have planted in their basic grains in order to grow green manure. They just won't do that. And they're right, they shouldn't. So what you do is you plant the lab bean, you plant it, you know, 4 seeds per square meter right in the middle of your maize field. And you plant the maize just exactly the way you have in the past. With Gliricidia, you plant 1 tree about every 3 meters going one way and 4 or 5 meters going the other way, perpendicular. And, you know, that won't affect the maize at all. You plant the jack bean, 3 to 4 seeds per square meter right in the middle of your maize field, and you plant them the same day you plant your maize. So you know it's very simple, and we aren't. If you rotate crops, then that means one season you don't have any maize there. You just have your green manure, and like I say, farmers won't accept that, and they're very right not to. By the way, where do you live in Malawi?
I live in the southern part. I'm in Plantas, but we are doing our projects in the lower Shire, like Chikwawa district.
Oh, Chikwawa. Okay. Have you ever heard of the program? It used to be CRS, and now it's a program that's run by Imagine Africa, an NGO that works out of Blantyre. Do you know about them?
Yeah, I'm aware of CRS. Is it Catholic Relief Services?
Exactly. Okay, well.
Yeah. I'm aware of what they are doing.
Okay, well,
here
I
in
will
Chikwawa, especially on
Okay, starting in May or June, I will be living in Blantyre, and I will be working with Imagine Africa, and we'll be working. We have a lot of work in Chikwawa and all the way down to Nsanje. So
wow,
you
that's
know,
incredible.
yeah, let's get together and we'll show you what some of the farmers are already doing. It's pretty amazing.
Yeah. If we go and see actually with our eyes and feel it, then
there's well over 1,000 farmers now that are planting Gliricidia, and you know, and the ones that have been doing this 2 or 3 years have already doubled their yields. So you'll be able to see very well what's happening.
Oh, great.
So
I look forward to that.
Be sure and write down my email when Xavier gives it to you, and we'll keep in communication. But hopefully in April or May, I will be living there in Blantyre and working with the people all through Chikwawa and that whole area.
Oh, great. I think you.
Okay.
I can't say more. I just wait to meet you here.
Okay, great.
Yeah.
We'll have lots of chance to talk.
Yeah, I'll get your email from Xavier.
Okay, great.
So the next question, we have a question from Pascal from Zimbabwe and then Diouf from Senegal. So
okay,
Pascal, if you want to go ahead.
Thank you very much, Zev, for facilitating this very important session. And thank you, Roland, for the presentations. I've jotted a number of points that I thought might be thrown across. But more importantly, let me first of all start by appreciating that this session is very important in the work that we do. And to mention a few in terms of the importance in our context is that we work in the southern regions of Zimbabwe, which is drought prone, and there are many challenges, issues to do with the drought we've been solving. But we've seen that there is great opportunity in terms of influencing and implementing a change in terms of land use. You see, farmers, especially those who are poor, usually they just grow maize, and this is weakening the productivity. And this challenge need be solved. And I found one solution: the green manure, the cover crops, is one solution, because we have to say, let's implement a change in terms of land use, not to change in terms of, not to change many things, but let's bring in new ideas, how we can resuscitate our land to be more productive. So this is one area. And in terms of the Mukuna that you mentioned, we are so happy that you have managed to help us to quantify in terms of the amount of can replenish back to the degraded soil. So you find that we've worked with the Mukuna or the velvet in Shavane, and the farmers have been using that for stock feed, and quantifying the amount of nutrients that we are replenishing back to the soil has been a problem. So what I think is very important as a take home and in terms of moving forward the agenda is to think of the policy, how we can influence the policy, how we can work with these institutions and strengthen them. And also working with poor and marginalized areas, and especially women who are vulnerable and who do not have much resources. It requires a value proposition. What is it that we are going to bring to them when we introduce the green manure, the cover crops? What is the social enterprise model that we can build with? I was thinking of, you see, this is very critical when we talk of cover crops, reducing labor constraints in terms of weeding, especially that is faced by women. We also have natural resource conservation, because in some districts like in the southern region where Elliot and myself work, we have about 40 to 60% bareness in terms of deforestation and degradation. And this increase when it is dry season, because there's no rainfall to stimulate growth in terms of the plants and the weeds. So we are saying we now have an opportunity in the mix in terms of reducing labor constraint, saving natural resources, saving in terms of the inputs. Because if we already have an opportunity to generate 240 kilograms of nitrogen or ammonium per hectare, we are saving a lot in terms of inputs, and also generating more income, and also it's gender sensitive. So I was also thinking of, in terms of moving forward this agenda, how best can we develop and design a best fit social enterprise model? Because we are saying, our farmers say, what is the value proposition of bringing this? Look, with proteins, with a lot of ions, with stock feed, you know, we've been relying on even the external feed, procuring feed for livestock. And this has been a trend in the past 10 years in our region. We didn't know that we have to provide the food aid for livestock, but this has been growing. And the cover crops are coming in now to bridge in the gap. And we've said, okay, can we now design a social enterprise model? Can we come up with a demo plot per region and also influence and move the agenda forward? And maybe lastly, and most importantly, in the Southern African region, we've seen a lot of destruction from pests, crop pests, like you see. Fall armyworm has caused havoc, and the locusts have affected the region. And do we have an opportunity or examples of these cover crops that can work as pest repellent, so that we can even save the yields that we are trying to stimulate? So these are my contribution, and I'm happy that the session is beneficial to our work, and I look forward in terms of working with you, developing a social enterprise model, bringing value to women and other smallholder farmers. I thank you. Over.
Okay, that's a long question and it has a long answer, so I won't be able to say everything I could. But first of all, the mucuna, or velvet bean, as you call it, and that's the sort of preferred English term, is a very good green manure, but it does have some problems, and so I would probably, if that's already available, people already like it and use it, go ahead and use that the first 2 years, because it will improve the soil. but it does have some problems. First of all, it usually dies in, well, there in Zimbabwe, it would probably die in April, May, June, which means it's not going to grow through the dry season. That's the first problem. The second, the only way to get it grow through the dry season is to plant it very, very late, like plant it in March or April, and hopefully it'll have enough rain to grow, and then it will grow through the dry season. But it tends to die whenever you plant it. It's going to tend to die in May or June. Is that correct?
Yes, that's correct.
Yeah.
Seasonal.
Which means it doesn't grow through the dry season, which means the leaves all fall on the ground, and then by the time you plant your maize, say the following November, the mucuna isn't fertilizing the soil very much, if at all. So that's one problem. The second problem is that it climbs. If you plant it together with the maize, like I've been saying, if you intercrop it with maize, you're going to have to prune it at least once, and that's a big job, because the mucuna grows very fast and very strongly. It produces lots of biomass, but it's difficult to grow together with maize, because usually what you have to do is plant the mucuna a month after the maize to keep it from growing too much, and then you still have to prune it once. Whereas with these other green manures, you don't have to prune them. For instance, so what I would recommend is once the farmers have had mucuna growing for a couple of years on their land, usually the soil will be a little better. And then by that, oh, by the way, what altitude do you live at? What altitude do you work at? Above sea level? Hello? Well, let me just say, if you're working at less than 1,500 meters, then after a couple of years of mucuna, a very good green manure would be Lab Lab. The Lab Lab has the advantage, first of all, that it provides human food that people can eat, which mucuna doesn't. Secondly, it's even more, the animals like it even more. It's even a better fodder than mucuna is. Thirdly, it fixes almost as much nitrogen as the mucuna does. Fourthly, it grows more slowly than the mucuna, so that if you plant it at the same time as your maize, the maize and Lab Lab will grow. The Lab Lab will grow more slowly than the maize, which means you don't have to prune it. And then the Lab Lab, the fifth advantage is the Lab Lab will grow clear through the dry season. If the soil is at all decent, and the maize has to have thick enough stalks so it will support the weight of the Lab Lab, but the Lab Lab will go on growing, as I showed you in the photo a while back. It'll go on growing through the entire dry season, and then it will fertilize your fields much, much better, because you cut it down, a week or two before you plant your maize the next year, and the leaves will do a very good job of fertilizing your next crop of maize. So I would do that. And furthermore, you can eat the leaves of the Lab Lab, which also people like. They like them better than they do cowpea leaves. In places where they eat cowpea leaves, they generally like in Mozambique, for instance, women really prefer the Lab Lab leaves to the cowpea leaves. So it's a wonderful plant. You can eat the seeds, you can eat the dry seeds, you can eat the seeds before they turn dry. You eat them as green, and they taste like common peas. And then you can eat them as a bean when they're dry. And so it's a wonderful, wonderful plant. It will grow very well if and produce a tremendous amount of biomass. I think actually it produces more biomass than mucuna, but it'll come, if it doesn't, it'll come very close. And it's a wonderful fertilizer. And also, frankly, animals prefer it. There are some large cattle growers. I met a few in southern Malawi, but also in Central America, that they grow their maize during the wet season. They grow the lab together with the maize, and then when the rain stops and they've harvested their maize and harvested their first lab harvest, they just put the cattle in the field. Close, if they have a fence, they close the gate. If they don't have a fence, this won't work. They close the fence and leave the cattle in there for 6 months, and the cattle eat lab and maize leaves until they've finished them all up. And they calculate the right number of cattle to be in there, and then when the cattle have eaten it all up, they open the fence, let them out, and the rainy season has started. In other words, they have the whole dry season, they have the cattle there eating just maize and lab, and they grow they continue to get fat during the entire dry season. So those are the sorts of things you can do with lab. These are all described in my book, and I would suggest you get a copy of the book. Okay, Xavier?
So we are reaching, there are only 5 minutes left, unless you want to stay longer, Roland, because there are still a lot of very interesting questions about pest control and salinity of the soil. So the next question is from Diouf from Senegal. Diouf, if you want to go, and then we have Benson from.
I'm happy to continue talking as long as people want to.
Okay. Diouf, if yeah, go ahead.
Okay, hello everybody. And my question was, if you may you one day try to your experiment in area where the soil or water has excessive fluorine or contains excessive salt, and what were the results? And what were the results you have?
Yeah. Basically, salt is a difficult problem. That's salty soils, that have been damaged by too much chemical fertilizer use without proper drainage and things like that. There's not much we can do about that. I mean, it's very expensive. Well, if you have irrigation, the easiest way to deal with it is to just flood the doggone field for, a couple of times. And that will help to wash the salt out of the soil. And then maybe you can get it to the point where you can grow things again. But salty soils is a very difficult situation. I gather from your name, you're from somewhere in the Sahel? Diouf?
Yeah.
You are from somewhere in the Sahel?
Yes, in the center of Senegal, we have the soil and the water who are salty or fluorine excessive content. And,
yeah. The salt content in the soil, virtually the only way to get rid of that without it costing a tremendous amount of money is to flood it. And during, if you have irrigation, flood it and let the water take the salt out or make the salt go further deeper into the soil where it's not going to damage your crops. But it's a very difficult situation. We can prevent that by not using chemical fertilizer and by doing other things like that. We can prevent it, salinization, but solving it is a big problem, and it's very expensive. Unless you have irrigation, then you can flood your field 3 or 4 times. Okay.
Okay, thank you very much.
Okay.
I'm satisfied.
Benson, if you want to go next. Benson is from Kenya and has a question regarding pest control.
Okay.
Benson. Read his question if I can. I can read your question, Benson. If you're not able
Where does he live in Kenya, by the way?
I don't know.
Oh, okay. Okay, go ahead. Ask the question.
So the question is, can you advise farmer to use chemical to control pests? And so he's asking that question because last year they had a challenge with aphids attacking labs. So
I didn't hear the last part.
oh, so the last year they had a challenge with aphids attacking lab.
Okay.
So,
Yeah, that's a common problem with lab. The aphids love it. And we've had that problem in various countries in Africa and also in Latin America. Aphids are very sensitive to dry conditions. So in some places, they've been the cheapest way to handle it is to spray. You grind up cassava roots and then put a little water in them and spray them on the plants. And when that dries, the cassava powder is very dry, and it will kill the aphids because they get too dry. That's one thing. It's the cheapest and probably the best, in terms of ecology, the best way. If that doesn't work, the only way I know is to use some sort of chemical. There's lots of chemicals that will control aphids. You'll have to use an insecticide. That's the only way I know. And of course, the other thing is, if it's really a terrible problem, if you're just completely losing your crop, then change to some other green manure. The aphids won't attack most green manures. It's basically just lab. So you can change to, for instance, if I were in Kenya and lived at less than 1,500 meters in elevation, I would probably switch to pigeon pea if you know how to cook it. The pigeon pea is a fodder crop. It's also it's a green manure crop. It really fertilizes the soil. And by the way, one of the advantages of pigeon pea is that if you don't kill it after you've harvested it, you leave it there growing after you've harvested, you can then, when it's time to plant your next crop, it'll have leaves on it. You can cut the leaves off of it as a green manure and then just cut off the stem at about 60 or 70 millimeters in height. In other words, up to about your waist. And what that'll do is it'll grow again. It grows for 4 years. So if you don't kill it and you just cut it off like that at about, like I say, about 60 or 70 millimeters in height at about your waist, then it will grow again. And the beauty of that is that it already has a good root system, which means it's almost totally resistant to drought. And you can do that for 3 years. It'll grow for a total of 4 years, which means 3 out of 4 years you have a completely drought-resistant food source, and it's also very good in proteins and so forth. So that's one of the big advantages of pigeon peas, and the aphids aren't going to bother pigeon peas. Now, if somebody mentioned the problem the locusts, the grasshoppers. That's a very serious problem and a very difficult problem. And I know in parts of Somalia and Kenya and Uganda, they've had real serious problems with locusts this last year. First of all, locusts usually only attack about once every 7 years. So probably next year, the next 3 or 4 years, you're going to be okay. The locusts are not going to attack. But the next time they attack, probably the best thing to have in your field along with your maize is jack bean, because locusts don't like they don't like the jack bean. So usually they'll fly onto other fields and won't bother the fields where you have jack bean together with your maize. Okay.
Mine is a comment. Hello, everyone. Mine is a comment. I'd like to appreciate this exercise because it really applies to the community partners that you are working with. In fact, I've just put on a comment on the chat box. Our economies are agro-based, and this will add a lot of value to the way that we're going to work with our community partners, because this concept applies, or in fact, it adopts an integrated approach. It applies ecological and social concepts and principles in the design and management of agricultural systems. And I think we're going to do work in a different way as a result of this meeting with Roland, and we're going to realize an improvement in the way of life of our community partners, because we're adopting practices which they already know, as well as coming up with new technologies which will enable our partners to resist the issues of climate change. Thank you. Thank you.
You're welcome. You're welcome. We're all in the same battle. We're fighting the same battle. And we now have the resources to win.
There is a question from Wellington from Zimbabwe, I believe. Wellington.
Thank you, Stephen. My question, I just want to seek clarification in terms of soil types. We've got different soil types. On which soil type this approach works best? So that sometimes we can pilot our model on a wrong soil type, and we can conclude that the model doesn't work. Are there particular soil type which it works best, and the soil types which it performs poor? That's my question.
I'm afraid there was an echo and I couldn't hear. Xavier, do you have that question written down so you can read it? Maybe I can understand it better that way.
Yes, Wellington was asking, so his question is if the approach work uniformly across soil. So if which soils are the best.
Now I missed a big part of that. Could you start over and do it again?
Okay. Yeah, I see my connection is unstable also. So it's about the type of soils. So he was asking if the approach that you described in the presentation work uniformly across all types of soil, or if there are types of soils that work best than others.
Yeah, basically it'll work in almost any soil. I mean, you know, there's some soils, for instance, I've come across in some places where the pH, the acidity is very, very high, especially in areas where people have used a lot of chemical fertilizer for many years. And that's almost impossible to deal with. But in most of the soils in all over Africa that I've worked with, and I've worked in almost all the countries you people are from, you know, there's no, we can use these green manure cover crops. Now, some of them, they won't grow too well the first year, but usually after the first year, the green manure cover crop has made it so that it will grow well. We've even used Gliricidia and jack beans in the what are called Kalahari sands of western Zambia, where it's white sand that goes down for at least 4 meters. It's incredible. It's like beach, like a beach on the ocean, you know. It's just white sand all the way down. And both Gliricidia and jack bean and even the pigeon pea did quite well. I was surprised. But so yeah, you can grow these in almost any soils. In fact, one of the things that farmers have a real hard time believing, so you may have to demonstrate it, is that you can take wasteland where you know nothing grows, where you can't even get decent pasture, and grow jack bean on it, and probably Gliricidia, and they will grow well, and the next year you can grow crops on a soil that they haven't grown crops on for 15, 20 years. So you know, you have to sometimes adapt the green manure cover crop to the situation, and if you're with really bad soils, usually the best one to try is jack bean. But you know, there are very few soils where these won't work. So, salinized soils is one case, and extremely low pHs that are below about 4.0 are ones where you know you're going to have a hard time growing green manures. But in at least 95% of the soils in Africa, even the ones that farmers have given up on, you can grow these green manures quite well. Yeah, Xavier?
I don't see any other questions on the chat, and I see that people in Zimbabwe are saying there is a curfew because of COVID, so they have to leave the office. So if others have questions, I think Roland is happy to stay a little bit longer. Otherwise, we will. I don't see for Roland.
Yeah, I can stay. Go to it.
I think that's it. Yeah, I don't see any other questions. So
okay.
I said thank you, Roland, for the 2 sessions. I think that was very appreciated. Thank you for doing that and for staying longer than we originally planned. And I hope that it will spark some more collaboration between organizations. And I will share Roland's email after the session, and I will also send a survey for your feedback. And we are hoping to be able to send Roland's book for people who want to have it. So I will communicate about that too.
Okay, great.
So
thank you very much.
All right, thank you, everybody. Stay safe.
Thank you very much, Xavier and Roland.
Thank you so much. Bye.
Okay, thank you. Thank you.
Thank you very much.
I hope I'll have a chance to work with some of you.
Thank you.
Okay, bye-bye.
Thank you.